Hi, Mr. Green here to take you through the next section of the waves topic of the GCSE Combined Science Physics Paper 2. Title today is What are EM waves, and your learning objective is to know that EM waves form spectrum and are grouped according to their wavelength and frequency. If you could pause the video and take that down as your title. Okay, we'll start as we always do with some retrieval practice. If you could pause the video and answer the 5 questions that are there. Okay, question 1. What's the difference between reflection and refraction of a wave? Reflection is where the wave bounces off the material completely, but refraction is where the wave travels through the material, but its speed and wavelength change which bend the wave. What's the imaginary line perpendicular to the boundary of a material called? It's called the normal. What's the wave equation? Wave equation is wave speed equals frequency times wavelength. What's the angle of incidence? That's the angle at which the wave hits the boundary between materials. And why do waves refract when entering a different material? When the wave hits the material, the wave changes speed and wavelength, and if it hits the material at an angle, the wave will bend. Okay, our learning outcomes today is to know that electromagnetic waves are transverse, to be able to name them in order for increasing or decreasing wavelength, and to give examples of electromagnetic energy transfers. So the EM spectrum. Electromagnetic waves are a group of waves that do two things. They all travel at the speed of light, which is 3 times 10 to the 8 meters per second, and they can all travel through a vacuum. All these waves will carry energy with them, and they can all, as I say, travel at the speed of light, so all travel at the same speed, and they don't need a material to travel through. They can travel through any area at all. They don't need particles to do it. They're sometimes called electromagnetic radiation, and they consist of vibrating electric and magnetic fields. So they don't rely on vibrating matter. That's the reason they can travel through a vacuum. The EM spectrum is a continuous spectrum of all the possible wavelengths of electromagnetic waves. You can see a diagram there showing the comparison between wavelengths between all 7 sections of electromagnetic waves. Okay, pause the video whilst you attempt these revision questions. We'll start it again when you'd like the answers. Okay, question 1. What direction are the oscillations in a transverse wave? So the oscillations of a transverse wave are perpendicular to the direction in which the wave is travelling. So they're at right angles to it. What's the period of a wave with a frequency of 20 Hz? Time period is equal to 1 divided by frequency, so the time period would be 1 divided by 20, giving us a period of 0.05 seconds. Describe a method for measuring the speed of a wave. Set up a ripple tank. Use a ruler to measure the wavelength of the wave. Use a stopwatch to measure the number of waves per second. And then your speed is frequency times wavelength. Okay, so the EM spectrum. There are 7 different parts of the EM spectrum, and EM waves with different wavelengths have different properties. Our eyes only detects the EM waves that fall into the visible part of the spectrum. In order of decreasing wavelength, the EM spectrum is radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Now you'll need to know them, and you'll need to know them in the order. So you need to know them in order of increasing wavelength or increasing frequency. So you're best to write a mnemonic to help you remember that. A mnemonic is where you would take the first letter of each of the part of the spectrum and then put it into a phrase that you think would be easy to remember. So have a go at doing that now. Okay, so all EM waves are transverse waves, and all EM waves travel at the speed of light and through a vacuum. EM waves are waves, so they will refract as well, and when a wave passes from one medium to another, it may refract, it may change direction. EM waves are the same as all other waves in which they will do that. So, pause the video and attempt these 5 questions. Now question 1. Are EM waves transverse or longitudinal? EM waves are all transverse. What's the EM spectrum? That's a continuous spectrum of all the possible wavelengths of electromagnetic waves. What are the 7 types of electromagnetic radiation in order of increasing wavelength? So we start with the smallest, end at the largest. It would be this order: gamma, X-rays, ultraviolet, visible, infrared, microwaves, and radio. Which type of EM wave has the highest frequency? Well, the highest frequency would have the shortest wavelength, so that would be gamma. And what can we say about the speed of different types of electromagnetic waves travelling in a vacuum? We could say the speed of any wave in a vacuum is the same. Any electromagnetic wave is the same, about 3 times 10 to the 8 meters per second, speed of light. All electromagnetic waves transfer energy from a source to an absorber. So we've got 2 examples here. A hot object, which is the source, transfers energy by infrared radiation, which is absorbed by the surroundings. Or the second example, oscillating electrons, which are the source in a radio transmitter, produce radio waves. These transfer energy to a receiver, where it causes the electrons in the receiver to oscillate, absorbing them. Electromagnetic waves can also produce changes inside atoms. These could be changes to the arrangement of electrons, or changes within the nucleus. We call the first set electron changes, second one nuclear changes. For electron changes, if an atom absorbs energy, some of the electrons in that atom will move to a higher energy level, or the different shell that's above it. When each electron falls back down to its original level, it produces an electromagnetic wave. Different atoms have different energy levels, so there's lots of different changes that could happen within atoms. So EM waves produced this way have a massive range of frequencies. The higher the frequency, the more energy it transfers. So an atomic change that releases lots of energy will produce a really high frequency electromagnetic wave. For nuclear changes, gamma rays are really high energy electromagnetic waves, which come from changes in the nuclei of an atom. What happens basically is unstable nuclei of radioactive atoms decay, and that gives out particles. After spitting those particles out, in order to become stable, the nucleus might get rid of some extra energy, and it does that by emitting gamma rays. Electromagnetic waves of different wavelengths will be reflected, absorbed, or transmitted differently when they meet a boundary, and this is one of the reasons different types of electromagnetic waves will have different uses. All electromagnetic waves with different wavelengths are refracted by different amounts, so that will affect what happens as soon as they hit the boundary of a material. White light is made up of all the wavelengths of electromagnetic radiation in the visible part of the spectrum. Each really narrow band of wavelengths corresponds to a different colour from red all the way to violet. Order of those are red, orange, yellow, green, blue, indigo, violet. Because each wavelength refracts by different amounts, when they enter and leave a prism, they start to refract differently and they spread out, and this is known as dispersal. This is why we can get the spectrum of light colours from putting light through a prism. It hits it at an angle, then hits it at a different angle, causing it to refract and refract again, slowing them down, and then you'll get the colours. Okay, pause the video whilst you answer these 4 questions concerning the electron and nuclear changes. We'll start it when you'd like the answers. Okay, so give an example of a situation in which electromagnetic waves transfer energy from a source to an absorber. Lots of different ones of these you could have had. I've given an example of a hot object emitting infrared radiation as it cools down. That radiation is then absorbed by the air around it, transferring energy to the thermal energy stores of the air. So our source was the hot object and our absorber was the air. 2 types of atomic change that produce EM waves: electrons falling to a lower energy level from a higher one, and a nucleus releasing excess energy after radioactive decay. What can happen to an EM wave when it meets the boundary between 2 substances? It can be absorbed, it can be transmitted, or it can be reflected. Will the same thing happen to any type of EM wave when it meets that same boundary? So will they all act exactly the same? The answer is no. Different wavelengths may behave differently at the same boundary. Okay, quick progress check and something for us to think about on these. So an electromagnetic wave source produces microwaves. The wave source is adjusted so it produces electromagnetic waves with a lower frequency. What effect does that have on the wavelength of the wave produced? Question B, the wave source is now giving out a different type of EM radiation. What type is it giving out? Pause the video whilst you attempt those questions, restart it when you'd like me to go through the answer. Okay, so question 1A. The wavelength would increase in that case. If we decrease the frequency, we increase the wavelength. So if it's producing microwaves and the wavelength increases, for question B, what type of wave must it be giving out now? Well, there's only one type of wave which has a longer wavelength than microwaves, and that would be radio waves. Okay, hope that was useful for you all. Lots of videos available on our YouTube site for you to peruse through and revise from. Thank you very much for paying attention here. See you all soon. Goodbye.